All right, so in the last video we introduced the idea of linear systems and solving linear systems, and there's three main ways that linear systems can be solved. And we're going to start with, I think, the easiest way to do it. It's not necessarily always the quickest way to do it, but I think it's the easiest, the most visually best way to do it. And that is to solve linear systems with graphs, okay, the graphing method. And this is one of the reasons you guys have been doing so much work with your linear functions and your graphing and all that kind of stuff. This is sort of what's been leading up to is starting to apply to this. And that's why, you're doing the parallel slopes, perpendicular slopes, y-intercept form, standard form, all those different things is to lead into being able to do this. Now, solving linear systems with graphs is really, 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 really simple. There's not too many steps to it. The first thing you're going to do is all you have to do is graph the functions. Okay, that's really the first thing you have to do is you graph the functions. So maybe you have like a graph or something like that, and you will then graph the functions. Maybe one looks like this, and maybe one looks like this, and that's it. And that leads to the second step. The second step is look for an intersection. And of course, the intersection would be right there, and that would be the answer to the question. So whatever the coordinates are for that little thing right there, that's the answer. It's just that simple. Now, of course, if they're parallel, then there is no solution whatsoever. If they're lying on top of each other, that's where you have the infinite solutions again, and that's a little bit different. But basically, we're just looking for an intersection is what we're doing. Okay, so it's just that simple. All right, so we're going to start by just doing some practice questions and on a sheet and sort of show you how it works. And we'll start nice and simple. So we've got a couple here right now. We'll start with these. It says solve each system by graphing. Okay, no big deal. These are nicely in y-intercept form, which is the easiest way to do it by far, so it's perfect. So if I just look at my first expression, start with this guy right there. It says y equals negative x plus 1. So my y-intercept, I know, is at plus 1 right there. And the slope is negative 1. It's negative x, so it's negative 1. So I just have to make a slope of negative 1. So I could go across to the right 1 and down 1. That would work nicely, something like this. And then if I do that, I'll get rid of that. If I do that, I'll put that right there. And I will then, of course, connect it with a line. Now, you need to use a ruler for this type of thing. Okay, I can use my fancy schmancy computer thing, but you need to use a ruler, nice and straight lines. Okay, so something like that. All right, then I will do my second expression, that one right there. And it says y equals negative 4x minus 2. So my y-intercept is negative 2, so start with that. There's my negative 2. And then my slope is negative 4. So I can do negative 1 over the one way, the other way. It doesn't really make any difference. If you go left or right, it makes no difference. But I want a slope of negative 4. So there's different ways you can do it. But you can do like a rise over run type thing, a 4 over 1. It just has to go in the negative direction. But 1, 2, 3, 4. If I went like here, well, that's convenient actually. That would be a slope of negative 4. So this one would look something like this actually. Okay, so it doesn't matter how you piece together the slope of negative 4. There's different ways you can do it, but that would be a slope of negative 4. The rise is 1, 2, 3, 4. The run is 1, and it's negative direction. All right, so now I'm just looking for an intersection. Do I have an intersection? Well, it's actually right there, conveniently enough. So my answer to the solution is where the two lines intersect, and that would be at negative 1, 2 would be the answer to the question. Okay, so that's how easy it is. Graph two of them, and then see if they intersect. Just that simple. Okay, so let's try another one over here. So I've got y equals negative 3x plus 2. Okay, so my y-intercept is 2. My slope is negative 3, so I'm going to go 1 across and 3 down. So it looks something like that. And I can draw a line as best I can, maybe something like this. There you go, that's not too bad. Okay, then I'll do the same thing for my other one. My y-intercept is negative 3. So it's my negative 3. My slope is 2. So if I even went over here, rise over run, my rise would be 2, my run would be 1. That would be me a slope of 2. And then I can draw line, something like that. And there's my intersection. So my intersection is right there. Okay, so that would be 1, -1 would be the solution for those guys. Okay, so that's it. I love doing graphing to actually solve linear expressions. You can see them really nicely. It works really well. Now these are all nicely in exact coordinates. When you don't have exact coordinates as your answers, it gets a little more complicated because if it's in between numbers, it makes it harder. But for this stuff, it's pretty simple. Okay. All right, so let's try these two right here. So the first one, y equals half x plus 4. So my y-intercept is 4. My slope is 1/2. So rise over run, okay, would be 1/2. So I could do a rise of 1, run of 2. So I could actually go right there. And if I draw my line, it's going to be something like this. Okay, something like that. And technically you could put arrowheads at either end, but I should try that for the next one. Then we got the y equals 1/2 x plus 1. All right, my y-intercept is 1. Plot that. And I got a 1/2 slope, 1/2. I'll even use my double arrow line, which I should be using actually. Something like this. Whoops. Oops. That's not my line tool. Where's my, there it is. Try that. There you go, that's better. Okay, something like this. All right, well, I don't have an intersection anywhere, and the reason for that, so I look here, my slopes are both 1/2. Okay, so since my slopes are both 1/2 and they're not on top of each other, these two lines are parallel to each other. So for this one, there's actually no solution for those guys. So that is what would be called an inconsistent system. So these guys are inconsistent, and we talked about those types of things before, and there's no solution. And if you've done this before, and some of you may have picked up on it right away, as soon as you see that 1/2, it's in y-intercept form, you know they're not going to hit. The only thing is you got to make sure the y-intercepts aren't the same, otherwise they'd be lying right on top of each other, and then you'd have a dependent system with infinite solutions. Okay, one more like this. Let's try this one over here. First equation, my y-intercept is -3, so there's my -3. My rise over run, 1/2, so rise 1/2, so I could do it right there. I'll use the proper one. This is better. Something like this. All right, and I'll do my green one. Well, let's see, my y-intercept is 2. And my slope is 3. So rise 3, run 1. So that'd be a slope of 3. And I can then draw again, something like this. Let's a little bit off. So I can move that over. Move this over a little bit. Oops. That's close. All right. So this is where the two lines are intersecting right about there. Now this isn't drawn super careful. It's probably supposed to be right in that coordinate right there. It's probably supposed to be right on there. But my drawing wasn't exactly super accurate. So anyway, if we do that though, my answer, it looks like about -2.2 and around -4.4 maybe. But if it was actually supposed to be on that coordinate right there, of course, it would actually be -2, -4, which is what it's probably supposed to be. So anyway, so you can sort of see the limitations of graphing sometimes. But I think my blue arrow should be up a little bit more, and my green arrow should be to the left a little more, and then put that right in the coordinate. But that's okay. Okay, we're just practicing the technique right now. All right. Okay, so this is the basic idea how it works. Graph the two of them, find the intersection, you're good to go. Okay, so let's try a couple more questions. So these guys are a little bit different because they're not in slope-intercept form, so I have to change them. So I have the first one here is 2x plus 3y is equal to 6. And I got to switch this into slope-intercept form to make it easier. Or you could use intercepts if you wanted to. It doesn't make any difference how you actually want to do it. You could put in the zeros for the x, get the y-intercept, put the 0 for the y, get the x-intercept if you wanted to. It really doesn't make any difference how you solve it, or you can just go for slope-intercept form. I prefer slope-intercept form, so I'll change this to 6 take away 2x, and then I would divide both sides by 3, so that'd be y is equal to 6 divided by 3 is 2, and -2/3 x, something like that. And then if I'd rearrange it into actual slope-intercept form. It'd be negative 2/3 x plus 2, something like that. And again, you could have done intercepts. It doesn't matter which strategy you use, as long as you get to something that makes you able to graph it a little bit easier. Okay, so let's see. My intercept is +2, so I'll put that in there. So my +2 is right there. My slope is -2/3, so I know the slope is going down. So rise over run 2/3. I know it's going down, so I can put a dot right there. Okay. Oops, reverse that one. Get rid of that. 2/3. So rise 2 run. There we go. That's better. That's a 2/3. There we go. That's better. Okay. So then I will draw my lines, something like this, and see if I can position that one a little bit better. You know, something like that. Okay. So there's my blue one. Okay. Now for my green one, I'm going to rearrange this one as well. So I've got 2x plus y equals -2. So I'll switch the 2x to the other side. So y is equal to -2, take away 2x. And then I'll just rearrange it. So -2x take away 2. Okay, so my y-intercept is -2. And my slope is also -2. So do a little rise over run, maybe something like this. All right, then I'll get my tool out for my line here. And, ooh, cutting close here. Something like that. I can move it over a little bit. Something like that. Okay. All right. And I'll try and extend this one a little more. Something like this. Okay. All right. Now again, this is drawn a little rough on a computer screen and stuff like that. I mean, it's not too bad though. It looks like they're intersecting right around here. It's probably supposed to be right there, that nice little coordinate system right there, but that's okay. I think my green line needs to be shifted to the right a little bit, but it's just to give an idea how this works. Okay, so if I did actually read it, it looks like my coordinates like -3.5 and maybe 4.5, but it's probably supposed to be -3.4 is probably the actual one. If this had been drawn a little more accurately on paper, it would be a lot easier. So, but anyway, graph it, see where the intersection is. All right, let's try one more. If you try this one right here, this one's a little different because the first one here, you got x is equal to 4. So x is equal to 4 is actually really simple because that's just a vertical line. Oops, where's my arrow tool? There it is. That's just going straight up and down, something like this at x equals 4. That's easy. All right, so for the green one, I should manipulate my green one here. So 5x plus 4y is equal to 8. I'll rearrange it. So 4y is equal to 8. Take away 5x. Divide by 4 all the way across. So y is going to be equal to 8 divided by 4 is 2. Take away 5 over 4x, something like that. And then if I rearrange it, -5 over 4x plus 2. Okay, so my y-intercept is 2. Right there. And my rise over run, my line's going down. It is a negative slope. A rise of 5. 1, 2, 3, 4, 5. 4, 1, 2, 3, 4. So right there, actually. And something looks like this. All right, so this one looks like I drew nice and accurately because bang on. So it looks like our intersection's right here at 4, -3 would be a solution for that one. Okay, so that's how you can solve stuff like this. So sometimes it's in y-intercept form, so it's way easier. If not, you have to either rearrange the expression, use intercepts, use whatever you want. There's lots of different methods you guys have taken in order to actually solve these things. But look where the two lines can cross. And when in doubt, take the numbers and put them back in. If you take the 4 and -3, this would be 4. Well, 4 is equal to 4. So that one is correct. This would be 4. This would be -3. Well, 5 times 4 is 20. 4 times -3 is -12. 20 plus -12 is 8. And that's one of the nice things about this. You can always plug the values back in to see if they work or not. It actually works really nicely. You can always check your answers with this stuff. That's one of the nice things about algebra. Okay, so that's how you can solve them using linear graphs.